about 3.2 complex numbers. And complex numbers really deals with the imaginary unit I. That's kind of the new piece to it. So imaginary unit I is, when you see I, it's really, oops, I guess I gotta select my pen here. I is equal to the square root of -1. Okay, so whenever we have the square root of -1, we call it I. All right. So in math, we've always said, hey, we can't take the root of a negative. However, there are times when we need to have some way to express that. Electricity, uses of electricity is one of those times. So we call that I. So really, like if I'm simplifying a root of a negative, I would just break it apart and call it root -1 times root 49 if I had root of -49. Root -1 is I. Root 49 is 7. So I call that 7I. Root -20, once again, we'll just take the root -1 out. Actually, let's show that. So that would be the square root of -1 times square root of 20, which would be I root 20. And then we'd actually want to simplify the root 20 to become root 4 times root 5. Perfect square of 4 goes into 20, so bring that I down. So we'd have I, 2, and root 5. And then this we would write as 2I root 5 is the correct format. Always put our real number first and then the imaginary. And then if we had, say, like -2 times root -25, go ahead and write -2. That's not part of the root. -1 and root 25. Okay, well that's -2 and I and 5. And all being multiplied there. So there, and there. And so that would be -2 times 5 times I, or -10I. Okay, so just kind of a little background on that. Really, a standard form of a complex number is A plus BI. Okay, A is our real part. So if you think of complex numbers as like it's kind of like a flow chart. Under complex numbers, you could have real numbers, which are all the numbers that you've ever dealt with. So real numbers would include like 4, root 7, -5, okay, 1/2. Okay, any number you've ever dealt with is a real number. And notice if we put a 0I at the back, really we're multiplying our imaginary piece by 0, so that completely disappears. So that would mean I still have my real number 4. Now the only reason I show you this is because when we're writing imaginary numbers in standard form, we kind of use that same idea. It's A plus BI, where B is not 0 anymore. Okay, so notice B here, B is not 0. And so when you have an imaginary number in standard form, or a complex number in standard form, we have that imaginary piece where we might have, say, 4 plus, rather than not having or having 0I, we might have 3I. So B is 3. So you put your real part first and then the imaginary part. Okay, so the set of real numbers and the set of imaginary numbers makes up the set of complex numbers. Okay, pure imaginary numbers would mean we don't have a real part to it. So notice in this case, A is 0. Okay, so maybe it's like 4I or -3I. Okay. Those would be pure imaginary numbers. There's no real part to it. All right. So what I'm going to start to do here now, we know that I is root -1. Okay. Well, I squared, it's important for us to know especially what I squared is, but I'm going to show some other patterns here. I squared would be root -1 times root -1. And anytime you multiply a root by itself, you get what's inside. So root -1 times root -1 is -1. I cubed would be I squared. times I, right? So you add the powers. That's the same thing as having I squared, which is -1, times I, which is root -1. So really, I cubed is negative root -1. I to the fourth is I squared plus, or times I squared. So really, we have -1 times -1, which is +1. And I'm going to stick with this I to the fourth because I like the number 1. So I to the fifth is I to the fourth times I. So really, I to the fourth, we remember, is 1. So we have 1 times root -1. Okay, 1 times root -1, which is root -1. I to the sixth would be I to the fourth times I squared. Well, I to the fourth, once again, is 1. So anytime we see I to the fourth, I'm just going to think of it as 1, which equals just I squared. And I squared is -1. Well, I to the seventh is I to the fourth times I cubed. And notice this just becomes 1 again. Okay, so really we just have I cubed, and we know I cubed is negative root -1. All right, so hopefully you're starting to see the pattern. I to the eighth is going to be I to the fourth times I to the fourth. Well, notice both of these become 1. Okay, and 1 times 1 is 1. So you'll note that the pattern starts over after 4. I is root -1, I squared -1, I cubed negative root -1, I to the fourth 1, and then we start over. I to the fifth is root -1, I sixth is -1, I to the seventh negative root -1, and I to the eighth 1. And so that means our pattern will start over here. We'll end up with root -1, -1, negative root -1, and 1. In fact, if we go backwards from here, anything to the 0 power is 1. And notice that's what we end up with when we go. This would be like I to the first. Okay, so notice if we went backwards from here, you end up at 1. Just like we go backwards from here, you end up at 1. Okay, so how does that help us? Well, that should tell you that anytime you have a power of 4, so any power that's divisible by 4, you're going to have a solution of 1. So I said, like, what is I to the 20th? Well, 4 goes into 20 evenly, so it's 1. And anytime I have an even number that 4 doesn't go into, well, like 2 or 6 or 10, I get -1. All right, and you can also calculate some of the other things, like if you had I to the 19th. Well, you know that that's right after -1, so we could figure out the even before or after it, and then figure it out from there. So we know that I to the 18th is -1, so I to the 19th has to be the next one, which would be I root -1, negative root -1, excuse me. And so really what you need to know, this is the big concept. I squared is -1. That, if you take anything else away, that's important there. Okay. And so I'm going to look at this. Find the value of x and y that satisfy the equation. 4x minus 9i equals 20 minus yi. Well, what I want to do is I want to say, well, 4x, my real part, equals 20. That means x has to be 5. And then I look at my imaginary part, and really, on the imaginary piece, let me switch up colors here, I'm saying -9 equals y. And so in this case, there's no math to do. -9 has to equal y. Okay, if that's -9i, and that's y, same, y would have to be -9. So you see problems like that. You're also doing some adding and subtracting. It's really simple. You add the real parts together. 10 plus 21 is, it is not 11. That's for darn sure. 10 plus 21 is 31. And then you add the imaginary pieces together as well. -6i and +8i gives me 2i. We write it in standard form with the real part first, 31 plus 2i. That's the standard form. Remember, that's a plus bi. Okay, and then we look at this one. Well, notice on this problem we have subtraction. And it's like having a -1 out here that we have to distribute in, or really, you're just changing it to plus and you're flipping all the signs on the inside of the parentheses. Okay, and then you have an addition problem again. So 17 minus 3i plus -13 plus 3i. So that would mean I'd have 17 minus 13 and -3i plus 3i. Well, in this case, that's 4, and these i's cancel out. Plus 0i is just 4. All right, so that becomes a real number. Let's go ahead and multiply now. Multiply and write in standard form. So just distribute kind of what you've done in the past. Pretty intuitive. -6i and positive 10i squared. Well, there's that I squared that I said. If we look back, remember I squared is -1. Okay, so that's like having -1 right there. So I have -6i plus 10 times -1. Well, that is -6i minus 10. Or, in standard form, is -10 plus or minus, minus 6i. Okay. And really, doing the same thing here, distributive property, there to there. So -35 plus 42i, there and there, positive 10i, and -12i squared. That ends up giving me -35 plus 52i minus 12i squared. There's that I squared again. I squared is -1. Okay, so really I have -35 plus 52i and -12 times -1. Or back here, that's actually positive 12. Okay, and so when I put that piece together, let me go ahead and write it here since I'm out of room. We'll separate those. Okay, I have -35 plus 12 plus 52i. Okay, so that gives me -23 plus 52i. All right, well, what else do we have here? We have some solving now. Solving using complex numbers, really it's just like solving any other equation. Subtract 15 on both sides there. End of 30 or 3x squared equals -12. And now you're going to take and divide by 3, but notice that ends up leaving us with a x squared equaling a negative. And when we take the root, we get x equals plus minus. Remember, you're taking the radical, so you got to do plus minus root -4. And that's the same thing as x equals plus minus root -1 times root 4, which we know as x equals plus minus 2 from the 4 and I from the root -1. Okay, so actually, maybe we should have, let's rewrite this. Let's put the -1 back here, so that becomes the I and the 4 there. Okay, there's our answer. We end up with 2x squared is equal to 40. Divide by 2. Okay, that's a -40, excuse me. So we have x squared is equal to -20. And then we'll take the root, so x is equal to plus minus root -20, which then we'll say, well, that's plus minus root -1 times root 20, which really is plus minus I, and we'll break that 20 into root 4, root 5, or 2 root 5. keep bringing all that stuff down. So at the end, we rearrange it correctly. So plus minus 2I root 5. Probably good set notation there. I haven't really mentioned that, but since you're adding multiple solutions, probably want to have set notation. Okay, the last one, find the zeros. And find the zeros just means it's when your graph crosses the x-axis, which means when something crosses the x-axis, if you recall, we'll just put two solutions there. You'd have something, comma, 0. So y is 0. And something, comma, 0. Your coordinates would have y equals 0 or f of x equals 0. So we're going to plug in 0 for f of x. All right, and we'll separate this a bit here. So we have 0 is equal to 2x squared plus 10. So we're just solving now. So subtract 10 from both sides. So we get negative 10 is equal to 2x squared. Divide by 2. Negative 5 is equal to x squared. Take the root. X is equal to plus minus root negative 5. And then pull that negative sign out. So I'm just not going to show the negative 1. I'm just going to call it I. We know it turns into that. So it's plus minus I root 5. So really another way to think about it when you're dealing with this is you could think every time I pull that negative sign out, it becomes I. That's another way to think about it. So like right here, when I pulled that negative sign out, rather than showing this step that goes to negative 1, I could just drop it right down there and say, well, it's just going to become I. Okay? All right, well, that's it. Good lucky.